So, just switch it to the... Oh, that's really big. Good. Good morning, everybody. At first they said, don't walk too much. I can't do that. It's just who I am, and I'm sorry about that. So this is, well, it's partly a brand new talk, and a quarter of it is not. And that's because I used it as the opening keynote for Fox Days in Amsterdam a while ago. And the funny thing is, that was like 4 or 5 months ago. I think, where's Go? I don't know, see where Go is. Oh, there. 5 months ago? Yeah, so, and since then, of course, well, this is about AI, right? So AI changes almost every day, which means I had to review what we do with AI and where we go and my worries about it. So most of it is brand new. So let's start with the idea of managers. These are the CEO and the CMO of the company I work for. And they said, can we be in your talk? I'm sure. I took their picture, now they're in my talk. And the CEO, he was under the impression that AI will take over everything. He watched a bunch of people who do, well, lots of predictions about what the future will bring, which is, of course, very hard. And he's like, yeah, it's going to take over everything, and we're going to run this company. It's a 120 people company with 3 people. I'm like, sure, why not? Let's do it, right? And unfortunately, our world of software doesn't work like that, right? We as developers, we know that it is inherently complex. And I'll show you how complex it is, actually, because I've been in this industry for a long time, so I've seen a lot of companies trying to work with that. And here's the main quote I always use to illustrate complexity, right? This is Esker Dijkstra. He's a very famous Dutch computer scientist, and he says, the programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. What he's basically saying, and this was in 1984, is that this field is so complex that you have no idea how to tackle it. In 1984, I was already writing code, by the way, in 1984. My screen was black, the characters were green, that's it, right? There was no internet. We just could write code on our machines. It would only run on our machines unless we put it on a floppy disk. If you remember, that's the save icon, right, for younger people. And you put it in another computer, you installed the software there, and it ran there, right? That was our world. And then already it was complex. But if you look at this is the tech stack of a company I worked for 5 years ago. This is complex, right? They had no way of handling this. They had 30 people in the tech team, and they could not handle this. They went bankrupt, to be honest. And that's terrible, right? So, and it gets worse, because if you see this quote, it says, well, 90% of the code accounts for the first 90% of the development time. And the last 10% of the code accounts for the other 90% of our development time. This is where we are, right? We have to squeeze too much into too little time. And the best illustration for that is actually the Cynefin framework. Have you heard of this? Have you seen it? It's a really cool framework to explain to your managers why we are in such a complex field. So if you're on the right side, either in the clear or the complicated zone, if your problem sits in the clear zone, that means there is a best practice. You apply it, done, get over with it. That's easy, right? We all can do this. You can even do this in waterfall if you want to. Same goes for the complicated side. Well, there's a bunch of alternatives. You have to pick one, you implement it, you build a code around it, done, right? This is like identity access management. There's like 4 or 5 good choices depending on what platform you're on, what cloud ecosystem you're in. Pick one, implement it, and it's done, right? Don't build it yourself, by the way. We've tried, doesn't really work. However, most of us are on this side of the diagram, right? We're in the complex and the chaotic zones. That means that there is no best practice. There are no good practices available. So what do? Well, practices sort of like evolve, right? They come forward from doing stuff. And that is exactly where most of us have been in this industry in the last 50 years. It hasn't been any different 50 years ago than it was now, except that point in time, 45 years ago, I had to look it up in a book. Remember those? We used to have them in ancient times, right? Things in paper and text in it, and you can say, oh, and if it wasn't there, you had to figure it out for yourself. That was not easy. These days, we have chat, right? And we can say to chat, oh, figure it out. And it does most of the times. However, this whole idea of AI brings in a lot of new things. And with a lot of new things, we are realizing that, again, software is still in the complex side, because we now have to sort of like embrace this AI world. whether we like it or not, we are going to, and it's going to change the way we write code. And I'll show you what it does. And then, if you haven't been in touch with AI that much, you're like, what is all this stuff, right? By the way, this image is, of course, generated by AI, and you're like, what do we do? Well, here's the thing. What do you do is this. So this talk is also a bit about strategies to stay on top of it, right? To make sure that we still have a job by the end of the day. And Liz says, well, if you're in these zones in Cynefin framework, you get into trouble when you are in either 4 or 5 of this. So people have done it, but not in our context, right? You work in a company, in a particular domain. I'm in an e-commerce company. How can we use this stuff? Have people done it before? I actually don't know. So how do you figure it out, right? There's only one way of figuring out. And that is what Dave Snowden, the author of the framework, says. He says, basically, if you are in a chaotic or a complex zone, the best way for leaders is to impel innovation, right? You need to innovate. You need to move. And the only way to do that is to experiment. That means try it out. It's basically the Nike approach, right? Just do it. Go out and do it. Figure out what it does. And by the way, an experiment is a test in order to learn something or to discover something works or is true. It could also be false, right? That means you have to be allowed to fail, right? If you can't fail in your company, you're not in the right company, basically. Also, not making decisions doesn't make it any better. You have to act now. And that's imminent. The change is always there, right? So we become this. This is a nice word I picked up. I'm not even sure. I was in Scotland 2 days ago and asked them whether this is an actual word in English. They didn't know either, so probably not. But this is what I tend to do. This is basically my journey as a developer. I travel purposefully toward an as yet unknown destination. You recognize any of that? That's what you do, right? You don't know where you're going. You don't have the exact requirements for what you need to build. You just don't know. And then AI comes in. And now what? Have you heard of vibe coding? Yep. Okay, most people have. 5 months ago, nobody has ever heard of this phrase, right? It was coined very recently. And that's with all of this AI stuff. So what is vibe coding? Well, let's see, right? There's a nice definition. It basically says it's an AI-dependent programming technique where a person describes a problem in a few sentences to an LLM, and the LLM turns it into code. Sounds reasonable, right? Well, here's the thing. This is what it says. It will allow even amateur programmers to produce software. This doesn't make our problem smaller, it makes it bigger. Because what will happen is, people like this is Elmo, his actual name is Elmo, and you can imagine what his avatar is. He's our content director. And he came to me and he said, you know what, I've been playing around with Cursor, so this is 4 months ago, right? I've been playing around with Cursor, and I actually built an app to run on my mobile phone, on my iOS operating system, in about a day, and it did all the work for me. And I'm like, yeah, did you take into account stuff like version control? Did you test it? You're like, test? You don't have to test this. This is AI-generated code. It works. Until it doesn't, right? So I started looking into that too, and I'm like, yeah, sure, let's use Cursor, right? By the way, we use Cursor every day these days, so it actually grew on us. So here's the thing. I started doing this, right? I was like, I'm doing a little bit of React. Let's see what it does. Can you take out a particular component from another component? And it said, yeah, sure, I'll do that for you, right? And it started doing that. And it says, well, you know what? There's some linter issues, and I'll fix the linter issues. And, oh, wait, this thing returns a void, but it should actually be a promise void. Sure, let's adjust it, right? And it starts adjusting the code, and it moves on, and then it says, oh, wait, there's another thing here. And it gives you a summary of what it does. So it says, well, I created a new node form component, nice, and updated the type to properly handle promises. It doesn't really work well with the rest of the code, but what did they care? Then I refactored the code to use async await, and I fixed all the type errors. Fine, right? It's pretty nice and neat. By the way, it got better over time. I actually dropped it after these experiments because I didn't like the way it wrote tests. But these days, it writes pretty neat tests, and it's actually better at writing unit tests, especially for UI components, than I can do. And then I'm like, you know what can I do with refactoring? And I said, you know what, we have a with agent interface. Please use that instead of just coming up with your own types. It's TypeScript, right? So, and here's a bit of the issue, right? we use frameworks, we use our own libraries, we use open source libraries, and they come with certain conventions, and we created certain things so that our typing system becomes better and easier to use. It doesn't know that. Well, it didn't know that. It does know a little bit better now. So it comes up with its own stuff. That means you have to sort of refactor it back into using your own code. And that's a bit where I got into trouble with it. I said, yeah, it says, yeah, I can do this, but this is the simple stuff, right? And it even says, the functionality remains exactly the same, but the code is not much more, don't repeat yourself. Fine, good, right? And then, well, we moved on, right? And I can say, well, could you just rename this function? It does all that stuff, right? It does the easy refactoring almost as well as WebStorm does it, right? So it's pretty useful. And that's fine. And then I went into unit testing. Now, this is where the trouble hit me. And again, this is a couple of months ago. So it changed over time. I'm like, please write the missing unit test. And then, yeah, sure. And then it says, well, I couldn't find where your unit tests sit. I'm like, well, I can tell you where they are. They're in the notes folder. Just go to test notes and they're there. Please put them there, right? And then it started creating all these unit tests. And I'm like, I couldn't find where I put them. And it still put them in a different place. It says, I put them in the notes, the underscore test, underscore notes test. Okay, that's not what I asked, but just please move it again and stuff like that. And then I started going into looking at the quality of the code. Now, quality is an issue, right? We know quality is an issue in software. Quality is basically hard. So if you go to the supermarket and you buy some coffee, the cheap coffee is always on the bottom, right? The expensive coffee is at eyesight. That's what they want you to buy, right? But it's expensive because it has inherently more quality. It's better roasted, it's better beans, it's better packaged, it's climate neutral, whatever it is, right? It makes it have more quality. More quality means more money. It's the same when you buy a new car. I didn't buy this one, it wasn't for sale, but it looks good on the slides, right? So it was in a garage I was in, actually. Pretty cool. And it's the same with, I drive an iPad with wheels, basically. Or basically, it drives itself most of the time, but well, unless it's in a garage, as it is now. But the thing is, better quality, more features, you pay more money. If you're willing to pay more money, you get better features, you get a better quality car, etc., etc. We are used to that model. And that means that every time when we do something, we look up the optimum. We try to figure out how much money are we willing to pay for how much quality. And we're used to that model. Managers in our industry are used to this model. But the problem is, software quality doesn't really work like that. Because when it comes to software quality, there's so many things that touch on, on what is quality in software that it is very hard to put numbers on. Also, actually, the funny thing is, well, it becomes a bit intangible, right? But the funny thing is that higher quality software is not necessarily more expensive, right? If you, a simple example, one very senior programmer could write better code or less code than 3 junior people will do, as an example, right? That's a stupid example, I know, but, and that could make higher quality software better. It's easier to maintain. It doesn't break that often. It is easier to test, hopefully, right? So all that stuff you take into account. And as such, the model for quality in software is different than it is in most places. And that means that we have to look into that too. So I was looking into the unit test, and it started doing stuff that I didn't count on. Right? We have our own very thin layer on top of a standard test framework because we want to be able to swap it out and make it simpler for our developers. So we created the renders wait method, and you deconstruct it into an add-ID function. And that ID gives you back the element in the DOM. But it doesn't know that, right? So it says, oh, you know what? We need to get the element from the add-ID. The add-ID already returns the element, but okay. So here is where it goes wrong. It makes assumptions that it shouldn't make. And again, it gets better over time because the tests we now write are better, actually. So, and it starts going in all sorts of weird directions. We use a markdown component in our forms. If you want to edit markdown content, people love doing that, or an HTML editor. And we use a thing called EasyMDE container. Actually, we start using a different one, but and it says, I want to be able to add some content in that field and then click on the submit button and see if that works. However, I couldn't reach that component. And then it says, yeah, it's basically because I said, well, I don't know how to add a value to it because it's a component I didn't make and I don't like looking into it. Could you please look into it for me? And it says, well, yes, basically it doesn't have a data test ID. And it's like, you know what, we'll just add one. See, on the bottom is just adding a data test ID. It doesn't have data test ID because it's encapsulated in what we do. Also, we're using another editor in the meantime, and it didn't know that. Well, it figured that out, and I'm like, oh, wait, let me look into this. And then it started sort of, well, it's not hallucinating, but it started coming up with all sorts of stuff that I didn't really want. Because it got back with like, oh, you know what, I'm going to use Fire Event. I didn't want to use Fire Event. We have our own implementation of that, which is fitting our needs better. And then it says, you know what, I'm going to mock out the whole component. And also I didn't want to do that because, well, that makes it very vulnerable. If you want to test it in another place, you need to do the same thing. And it got worse and worse and worse. And then it says, oh, yeah, we'll do this. And then, well, sorry, it said also, it doesn't have a value setter. Yes, that's where it started. I want to be able to set a value in that field. And then I went full circle. It took me not half a day, but 2 hours to get back to the same point. And I was back at square one. And you see that a lot if you do AI-assisted coding, right? It happens a lot. You talk with it, you converse with it, and eventually it comes back to the solution where your original question was. And you're not further than you were. That was the case a few months ago. So we thought, well, let's just go back to chat and just go back to Copilot in our WebStorm editor. So we did. And then I was like, I want to be able to mock out the responsiveness of Windows in my browser and see what I can do with it. And I couldn't figure it out, right? And I said to Chat, well, what do you recommend? And Chat said, I recommend you to add just mock window, which apparently seems to be a library. Just mock window. Sounds nice, right? Just mock window. Just yarn it and see what happens. I couldn't find it because it doesn't exist. So it gave me a recommendation which didn't exist, right? Think about that. And then you see a lot of posts online about this stuff, right? Here's Lovable is another IDE, AI-assisted IDE. And this guy says, you know what, I'll just turn my LinkedIn profile into a website. Pretty cool, right? And then somebody says, yeah, please make sure that your API keys is now exposed in every request. That's not a very sane thing to do, right? About this guy, this was also cool. He says, my SaaS was built with Cursor. 0 handwritten code. Pretty cool if you're not a coder, right? So AI is no longer just an assistant. It's also the builder, right? And it was pretty happening. He published that out. And then a few days later, 2 days later, he says, guys, I'm under attack. Ever since I started to share how I built my SaaS using Cursor, random things are happening. Mixing out usage on API keys, people bypassing subscriptions, etc., right? The code wasn't really very much secure, but he didn't know that and not being a developer. And that's particularly where the problems are, right? This is it. Jason has the best quote, I think, for it. He says, having a code generation tool that gets 80 to 90% of the work done is like a boat that takes you 80, 90% of the way. You still have to be a very good swimmer. And that is where the problem lies. So that's where we were. And we were like, what are we going to do with this, right? Are we going to just let the whole team work on these tools? How much technical debt will they actually start creating? And what about standardization in our frameworks, right? It couldn't handle that at first. So we were a little bit in doubt. So it feels a little bit like being in the Matrix, right? It's like you either take the blue pill and you go on happy with your life, and you'll probably stop being a programmer because you're replaced by AI, or you take the red pill and I'll show you how deep the rabbit hole really goes, right? So this is a good point to introduce myself because we were there a couple of months ago and we didn't know what to do. We already had started using some stuff and we got better at it. So this is me. I'm Sander. I'm a single independent dad. I speak a bit, I write a bit. I usually do CTO roles, and I'm a lifelong programmer. I've been writing code since 1978, and I'm actually making a living with it since 1987, so I've seen a bit of this industry. I'm currently the CTO for a company called iBoot, which is an e-commerce company in the Netherlands, which has daily new deals, which makes it harder to do the automation on it because it's very different than a regular web shop. That's their business model. I can't help it either. Just to show you that I'm a programmer, this is me. I'm actually double object-oriented. It's my parents' fault. I prefer functional programming, but figure out a last name that contains FP, right? So also it gets worse because this is where I live. I actually live on the Java street in Amsterdam. It's pretty cool. They didn't have a TypeScript street, so I voted for the Java street, right? So pretty cool. And I'm a part of the authors of this open source framework as well, which is a TypeScript framework for doing microservices. So yeah, so everything I tell you, and that's probably the best thing I can do, is just show you what we do with it, right? And not some generic story about what AI is and la 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 la. I'm just going to show you what we do with it because I thought, well, that's my addition to what I can tell about this industry is what do we do with it, right? So there we go. We took the red pill. Now, taking the red pill means you go full head first in, right? You just start trying things out. And so we're like, what can we do with AI? And I was talking to the management team last week. I'm part of the management team, so I talk to them regularly. But and we came to this conclusion. I'm using the same picture. It's not that they say everything well. They were standing here, but it's just a nice picture, right? And the CMO said, well, the thing we noticed in the last couple of months, in the last 6 months more or less, is that the problems you as tech are now solving are problems that we could not solve before. And that's the thing, basically. It's writing code to solve problems is all well when it's deterministic, right? When you can actually decide based on some values and you say, okay, go left or go right. However, when your domain is non-deterministic, to give you an example, I want to create a campaign from the website given there's an event somewhere in the Netherlands taking place the next week, so we can type the campaign to that particular event. Like we had this, what was it today? Neighbor Day. We had Neighbor Day, I think, last week. None of the marketing team knew that, actually. The AI figured it out, right? It says, well, there's Neighbor Day. Would you want to create a campaign for Neighbor Day? I'm like, yeah, cool. So what should we put in it? And we said, well, here's the API to the stuff that we have on stock now. Go figure it out. And there's 5,000 things that we haven't said. How do you connect products to a campaign that is just a single sentence saying it's Neighbor Day? This is typically the stuff we could not solve before and that we can sort of solve right now. And I'm saying sort of because it's not perfect, but it goes a long way. So I'll show you a bit about where we come from and what we do with it, right? So a very short history of tech. This is how we are conceived, right? This is what people think we do. Well, not necessarily COBOL, but other ancient languages, and every programming language is becoming an ancient language by now, right? We type. That's what managers think. We type. We type 8 hours per day, and then we go home. And we have dinner, we do some things, we sport, come back the next day, we type for 8 hours, and we go away again. That's what people think we do. But that is not what we do, right? A large part of our work is not writing code. The larger part of our work is actually thinking, right? This is what we do. We think. We are paid to solve people's problems. We listen to people, we talk to people, and then we're like, oh yeah, let's do this and go there and do that and do that. And the typing part is only the last part of it, right? And it's not the bigger part of this. So yes, it is useful, but remember, we are problem solvers, right? So to answer the question, whether we're going to all lose our jobs in the next year, we're not. Well, especially not in the next year. Maybe in 2 years. No, I'm just kidding. We're not going to lose our jobs because we solve the problems, right? Solving problems is done by thinking, not by clicking on a keyboard. So where did we go? Now, we started taking small steps. So one of the first things we do is I like to encapsulate stuff. Why? Well, in this particular case, I wanted a service, so we're building a microservices platform, right? So one of our services is the one that talks to the large language models. And I don't want to have to take into account that I rebuild everything for every prompt on a different model. I just wanted to say, use this model, and then the prompt service will figure it out where to go. And that is a very useful thing to have, actually. So that's what we did. And I'll show you what we did with it. We started creating content first. So I'll show you Postman. It's a bit dark, but I hope you can see it. So this is basically how it works. We go to the prompt service, to the prompts endpoint, and we say, I want the prompt called AI campaign. And I'm going to pass in the engine that you need to use, Gemini 2, Flash, and the output needs to be JSON. This is the parameters we give to it. By the way, the prompt is a piece of text that we keep there's the UI to that, so our content people or whoever is in charge of this particular prompt can edit the prompt themselves. Because a large part of what people are doing now is improving prompts so the results come out better, right? And that's not our job, that's the business, it's the job of the business to do that. So the marketing people do that, the content people, the purchasing people do that. They edit the prompts and they make them better and see what comes out, and they have a screen to test it as well, and then we use it in production. So what it does is this, right? I asked, give me a campaign using Gemini 2 Flash, and it came up with this. I did this morning actually, so this is totally fresh. It says, cozy autumn nights, embrace the fall season. Well, it's still 27 degrees here, but in the Netherlands it starts raining by now, right? Get ready for cozy nights with our curated collection of blankets, candles, and comfort essentials. It just made this up, right? It's pretty cool. We, as developers, couldn't do this. We can make it happen, but we couldn't do this ourselves because it's non-deterministic. So, and the content people can do it later on, right? They can do it for all the offers that we have on the site. They can actually click here and say, you know what, I'm going to edit this thing, and actually I'm going to regenerate using any of these models. By now we have a lot more models, but it doesn't matter because they're all encapsulated in the prompt service. So for us, that was a very good first step. So we could do lots of stuff already with this basic functionality, hiding out the fact that we're using different models from different providers, et cetera, et cetera. So then we were like, you know what, we're gonna give it our data so that it can work on our data. And that's the next step up. So we start doing that, right? And we started looking into invoice recognition. Now, invoice recognition is inherently a very complex domain, right? It's where there's vendors that have tools to do OCR and all that stuff. And our finance department was looking into acquiring one of these tools, basically. And we're like, what if we spend like a month, maybe 2 months to figure it out ourselves, whether we can do this? Because AI. And 2 people on my team started building this stuff, and it actually came a very long way. Now, this is a process view. We do a lot of things in process, so I'm going to show you a bunch of these. And it actually goes from left to right and then goes into the second line. And what you see here is all the steps that the process for the invoice recognition takes, right? We extract the invoice data, then we try to recognize the invoice, which is an agent that we built. And we do lots of small steps with it, and we try to get the information, the supplier, the PO number, the actual order lines to see whether they're actually already arrived, whether they are in stock, et cetera, right? We do all that stuff in a single process. Invoice comes in, a lot of data comes out. And the nice thing is that people were questioning, yeah, but this does our job, right? Yeah, that's true, because one person in the finance department doing all of this stuff manually could do like 11 to 12 of these invoices per day, right? That means we had a lot of people on board to actually do pretty stupid stuff, like take the PO number from the invoice, try to figure it out in the ERP system where it exists. If it exists, add the supplier to and then go through all of these order lines, see whether the stock has already come in, and if it all came in, then you approve the invoice. That is typically stuff that we can automate by now, and we do that. However, there's always the human in the loop still, right? Because we do want to validate whether the AI is actually making sense. Sometimes it is, sometimes it's just not. And then we moved on, and we're like, what if we also go out on the internet? We had to wait until OpenAI offered this to actually include data from the web. So we give it a bunch of websites, and we said, please go and look here, because what we wanted to do is for all the products that our suppliers want to have us sell, we need to figure out what the best online price is, because we need to go below that price. And we start doing that, right? So we basically said, now, also go out on the net, visit these 10 websites, scrape the product pages that you can find on this website for this particular product, and give us the price back. And then we'll figure out what the best online price is, and we need to go below that price. Now, that, again, would be very hard to do that. By the way, we even allow it to go into these websites, and you can click on it and see whether it actually works. Now, that would be very much impossible to write in code, right? You could probably pull it off, but you have to know the structure of each of these websites. And when these websites change their structure, you're doomed. The AI figures that out. Oddly enough, right? It does that sort of thing. It's pretty cool, actually. And then we moved recently towards this thing which is called the Responses API. Now, this is one step up, and we've been using this thing for a month and a half by now, I think. And it's an interesting interaction with the AI. So what it does is, from our prompt service, we do a post request to OpenAI. OpenAI is going to look into that, and we're going to pass into it a bunch of tools, which is basically a JSON-defined thing that we propose it to use, basically an API call in our landscape. And it will go start reasoning, and then it will say, oh, I want to call on this tool, and it comes back with a reply. And we then, from the prompt service, call on the other services in our landscape and pass back the reply. And of course, also the conversation ID, so it knows where to continue, and then it does. And that's a very different way of interacting with the system. And it's kind of nice. And we use it to generate new products. So on a new product, again, this is a process. For every new product that comes in, we need to know a lot of information about all sorts of taxes, whether there's a battery included, whether it has home copy protection, whether there's what's all sorts of, what the shipping costs are for this particular product, because that all takes into account for how much we would be able to sell it, right? And we take all these steps, and there's more. So this is the second part of the same screen. All of these steps are executed, and most of them are actually small agents that interact through the responses API. I'll show you one example. There's this text called the we, actually. It's a weird phrase. I never know what it means, but I looked it up. So, and I'll show you how we work with it. So this is OpenAI. This is chat, basically. And this is where we've defined this particular prompt. So this prompt doesn't live on our landscape anymore. It lives in the OpenAI environment. Now, that's a big change, right? And what it does, it says, well, there's the get rule types thingy. And what I did, I typed this in this morning. I said, well, if I'm in the Netherlands and I have this product called an LG 50 4K whatever TV, is it subject to the WE taxes, which stands for Waste, Electrical, and Electronic Equipment Directives? Okay, it's a type of taxes. So I asked it, is it subject to WE taxes? And then it says, I need to use this assistant, right? It says get rules type. I want to call on that function. So it comes back to us as a response to the post, and we say, okay, we'll execute it for you. So this is what comes out, and then it draws a conclusion. I think I have the conclusion on the next screen. Yeah. And it comes with a conclusion. So this, again, is from Postman. It's the same call, basically. And it says, well, it's in this particular category, and as a result, it means that we have to pay these taxes. And yes, it does fall in the WEEE tax community. So this is another way of interacting with OpenAI. I'm not sure if you've seen this before, but this is a step up, I think. It makes conversations with the AI possible using the APIs in your own landscape, sitting behind a gateway, basically. So we also, a little bit? Okay, cool. Yeah. I'm not sure if you can still see me, but let's just continue, right? Otherwise we'll be here the whole day, right? So, so this is what the AI started doing. I hope my remote still works, otherwise I have to walk back to my laptop. So this is what the AI started doing when we call it using the responses API. It tries to figure out interesting campaigns, given on the fact that we just talk to it and say, listen, you need to go out on the web, figure out what's actual in the different countries that we work in. Like in Belgium, we have different holidays than we have in the Netherlands, right? And the same in Germany and Poland, etc. So here it finds out Neighbor Day. This is from yesterday, from 24th September, so it's from Wednesday. And it figures out, hey, there's Neighbors Day, so maybe we should issue a campaign for Neighbors Day. Now, that's all interesting stuff. And then we recently figured out this thing. It's sort of starting to mature a little bit. It still has a lot of security flaws, but this is probably the next step that the AI vendors want you to take. And specifically, I'm saying that they want you to take. I'll illustrate the reasons for that later on. So here it is. This is called Model Content Protocol. It's fairly new. It was coined in November, the whole phrase, and it didn't pick up until a month or two ago. And then all of a sudden, everybody starts doing this, right? All of the vendors are providing what is called an MCP server. Now, normally, what you would do is, well, even with the responses API, you go to the prompt and you say, well, please execute this stuff. And here's a bunch of tools that you might use. The thing is, with the responses API, you have to configure those tools yourself. Now, with the MCP, what you could do is you create a small server on your own network, on your own, wherever you are, that adheres to a particular protocol. So now the AI is going to go into that server and it's going to ask you, so what things can you do for me? And from those things, it might choose to use one of your tools or a bunch of your tools to come up with the answer. So here, the LLM is much more in control. And it's usually very much JSON-like, so it responds in JSON. So that's all fine, that's good. And that means you can actually, you only have to define those tools once, because they live in your server. That is why they're sort of secure, but you still have to make sure that the AI can reach into your server, right? And that's, they haven't figured out completely how to do this securely. So there's still some issues with it. But it's a promising technique. We haven't looked into it yet. We're on the verge of looking into it because that's how my team rolls. It's basically saying, okay, if there's something new that might be useful, we'll just look into it. And that is also the part where I'm going to try to help you a bit. Where can you go and what should you do with your teams in order to make sure that you can keep up with what's happening in the world? I'm going to skip this one. The shorter thing is, if you use the responses API, that's basically, here's the prompt and some tools that you might call on. Come back to us and if you need one of our tools, and we'll figure it out for you. That's a very chatty interface. And with the MCP protocol, it becomes much more that the AI is in the lead, and the AI is going to ask to your server, saying, okay, give me, what tools do you have? Given this particular domain, what tools can I execute? Can I get your products that you have in stock? Can I get your taxonomies? Whatever, right? Whatever it thinks it needs to solve the puzzle. So that is taking it one notch up. And the interesting thing about this model is there's large vendors actually supplying service like this, right? You can go to Google and say, okay, I want my Gmail to work with that, I want my calendar to work with that, and you can just say to your MCP client, being OpenAI, Gemini, or whatever, just go there and put an appointment in my calendar. Now, I still find that pretty scary, actually, to be honest, but well, it's sort of starting to come up. So again, the thing is, we now can solve problems we couldn't solve before. And that is actually true. We have solved so many business issues over the last half year that we would have never dreamt of being able to solve like a year ago, right? And it goes really, really fast. And the thing is, you probably need to keep up. Now, I have a bunch of worries, and I need to go through with them. And this is the first. This is a guy called Sam Altman, and he worries me, basically, because he's sort of trying to claim world dominance. A smart guy, though, and he's like, yeah, we should be able to train our models based on copyrighted stuff, right? And it's slowly getting on edge of what I think is still ethical. And also, the question is, how much smarter are these models going to get? Because by now, they have eaten the whole internet, basically. You can find everything. When I was in Asia on holiday a couple of weeks ago, and I didn't even Google anything anymore. I just asked Chat or any of the other AI instances to say, well, listen, I need to go on this boat, and I need to know where to buy tickets. I was in Edinburgh yesterday. I needed to buy a ticket for the tram. I asked Chat how to get a ticket for the tram. You don't Google anymore, right? The whole idea of a Google engine with lots of answers is gone. It just provides you with the best answer, and it gives you an explanation why that is. So it is literally changing a lot. It's also scary, right? This is the thing that scares me the most. This is our spend on OpenAI, and we use it to generate content for all our products, to translate content, to do lots of stuff. And marketing uses it even more. And this is our daily spend, right? And it does never go over $100. That is not what this thing costs, right? It's way more expensive to run our prompts than the $100, or even like yesterday, it was probably like $10, right? How much can you get for $10? Quite a lot, but that doesn't pay for it. So at some point, people are going to want to make money from AI. And those people are the people that pay OpenAI and that pay for all the other companies. And they're going to want money out of this, which means it's either we find cheaper models or the prices will go up. What if the prices do go up? Is it still feasible to use AI in your daily processes? What if it isn't? What if it becomes so expensive, but you just built your whole company on top of all these prompts? What do you do? Nobody knows. And that's the tricky part about it. Also, there is a complete vendor lock-in, right? Once you start doing this, especially once you go into the responses API or MCP or any of the other protocols, AP2 for instance, you are doomed to get stuck inside of OpenAI or inside of Gemini or inside of any of the other vendors, right? This is vendor lock-in 2025. You're never going to get out again because we now have like a bunch of these conversational AI agents. We're not going to rebuild them on any of these other tools because that takes work. We don't want to do that work. But what if we end up with 50 of them, or 100, or 200? Who is going to control that, right? We need some sort of standardization. And we are sort of almost on the way that we say we need to standardize that. And now, the real problem, I should have taken a picture about 10 minutes ago. We had an outage this morning in the hotel. We couldn't even get coffee. The coffee machine shut down, right? Outages. Do you think OpenAI has outages? What do you think? It does. I'll show you. They actually are very open about it, right? These are the outages of ChatGPT over the last month, or from June to September, actually. There's lots of reds and there's lots of yellows, which means you cannot reach it. What do you do if at a particular point in time you need some business critical stuff? Where do you go, right? And it's in more detail, it says this, right? Every day there's outages, right? We could not get ChatGPT on WhatsApp. Increased error rate for ChatGPT. There you go. That is an issue, right? And the big issue for us developers is this. It's technical debt. Technical debt is a serious problem. We all have technical debt, by the way. There's no exception. We do. We have it too, right? So Ort Cunningham, who invented the phrase, says, a little debt, well, shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with refactoring. Nice that he uses the word promptly in 1974, but yeah. And the problem is, entire engineering organizations can be brought to a standstill under the debt load of an unfactored implementation. Whether that's, there was no agent back then, right? But think about it, it will hit you. And here's the thing. Edgar Dijkstra was right again. He says, if debugging and testing probably is the process of removing bugs, then programming must be the process of putting them in. Right? So the trick is not to put bugs into your code. Is that hard? It's extremely hard. A good friend of mine, Jules May, he is confident that he can write and he can teach people how to write code without bugs. And to anybody I talk to about this, that Jules has this claim, and I believe him, he just hasn't taught me yet, everybody's like, no, that's not possible, right? We all are okay with the fact that we include bugs in our code. Why is that, by the way? So what if we let the AI write the code? The problem gets worse, right? The thing is, and that's the thing with Cursor as well, right? As soon as it starts to refactor bigger things, it's easy to lose track of what it all does, right? If it changes 20 files on one go, and you just please commit it. You haven't seen all of it, right? That is an issue. It's going to introduce technical debt, because also Cursor or any other AI doesn't know how to write faultless code. Only Jules May knows, right? And, well, he's in Edinburgh, so he's in Scotland, actually. So the AI technical debt will start to infer costs as well. And you need to get that out. That's probably going to be our work. And again, Jason's quote is good, right? This is what it's about, right? It does not do the complete work. You still have to be good at what you do. And that is why we're not going to lose our job, unless we want to be here, right? This is where a lot of companies are actually going to. They're going to be at a bigger speed, going to a phase where they spend all of their time just keeping the code alive. And if we include all of this AI-generated code, which I'm not saying not to do it, we need to take into account that this might happen. So you need to have mechanisms in place to make sure that your quality is still okay. One last thing, but there's just all sorts of small companies that come up and managers believe that they will solve all their problems. I got this message 2 days ago from our COO. He said, well, congratulations on the good technical start of the hunt. Could you look at to replace Dolly? Dolly is the person who does the fraud detection in our company. And she's going to do something else because somebody else left. I've blanked out the name of the company, of course. It's an AI-powered fraud detection that learns from a federated network of merchants. This is bullshit, of course, right? It's 2 people in a back room in Amsterdam, coincidentally, that just get a thin layer on top of some AI and sell it as a product. That's going to not last very long. Most of these small companies will disappear in half a year because that's the point where you can do it ourselves. We are implementing a chatbot for our CS department, customer service department, and the developer on my team who implemented it and used some tool from the internet, which is pretty expensive. He said, why don't we just write a prompt to it and we just put it in a responses API, giving it the orders and the claims. We get much better results. So we're doing that, actually, right? That company is going to go out of business. Lots of these companies will, actually. So back to my team. What do? Why can we keep on top of this? First of all, my team is not a really big team. This is my team. Well, where is it? Where's my team? Oh, it'll show up in a sec. So we thought about that, and we were like, we need to be doing 3 things. We need to look into, and it basically comes from this book, right? We need to look into, do we have a direction to go to? Well, we saved the company. That's enough direction, so I'm not going to go into that. We need to be good at what we do. How do you stay on top, and how do you stay good at what you do? And the third part is autonomy. I'm going to start with that part. Autonomy, I think, is crucial if you want to stay on top, if you want to be able to experiment, right? You need to allow yourself to do that. So everybody on my team can do this. And that's my recommendation to you too. Autonomy, however, is really hard, right? How do you teach people to be autonomous? How do you allow them to be autonomous? So besides being one of the programmers on the team, I'm also the manager of the team. I don't really like that, but it's still it is, basically. And for most people, having to decide for themselves is pretty hard. And it's not as easy as you think it is. So I had these conversations with people on my team for a long time, like 5 years ago, like, yeah, but what do you want me to work on today, right? Do you want me to work on the new TypeScript stuff, or do you want me to work on the ERP system? I'm like, you figure it out. It's your work. It's your responsibility. I don't know how to make that decision. You know much better than I do. And then she said, well, yes, but what do you want me to work on? And it took time, right? It took me 4 months of these conversations daily with her until she got to the point that she actually is now very much committed and making her own decisions. Now she says, I'm not going to release the ERP system on Friday this week, and everybody wants that because you didn't test it, people in the business. You need to test it. And if you don't test it, I'm not going to release it. That's a pretty big step up, right? So she's taking the responsibility, and she owns the thing that she does. The question is, how do you get people to do that? It's like tell them to draw an owl, right? I can draw 2 circles, and I say, well, you need to figure it out by yourself, right? That's the hard part of it. And you learn by doing that. And that is crucial, right? Just go out, do it. Try it. Dare to try it, basically, and allow yourself to fail. That's why yesterday, one of the guys on my team, he says, you know what, I found this blog post. Should we try this? And 2 other people said, yeah, let's try it. And they're probably now trying it out. The week before, they try out N8N. Was a nice experiment. We're not going to use it for now. We will use it for testing purposes for ourselves. But again, this is what allows people to go out and figure it out for themselves. And the only thing I could figure out how to do this is to take away rules. Rules are the contradiction to autonomy, and I'll show you why. So this is a crossroads near where I live in Amsterdam. And at some point in time, the city council decided to do an experiment. And they said, we're going to take away the traffic lights. And we're going to take away the signs, most of them actually. And you go figure it out for yourself how to get across. And everyone was, no, there's lots of accidents going to happen. Well, they do, because I crossed this thing a couple of weeks ago, and I got my bicycle in the tram rails, and I smashed my face. But other than that, usually no accidents happen. But and the reason is that people who come to this crossroads, they will actually start communicating. Non-verbally usually, or sometimes verbally, very verbally, but not a lot actually. So you look into the eyes of the other people that are also coming onto the crossroad, and you see what their intentions are. And from those intentions, and they see your intentions, you figure out what to do. And that rarely goes wrong. So you let other people pass, other people let you pass, except when there's a BMW, right? So you just let them go by. You don't communicate with these people. It's like, they're crazy anyway if they drive through the city. Or the tram, right? It doesn't matter what you do, but the tram goes first, right? But you know these rules. There's small part of rules that's still remaining. Most of it becomes communication. So that is basically what we started doing. And it all comes down to this. Dee Hock is the CEO of Visa, or he was actually at some point, and he says this: simple, clear purpose and principles give rise to complex and intelligent behavior, right? Complex rules and regulations give rise to simple and stupid behavior. So figure out which of the two you need to stay on top of everything that's happening in AI, because it changes so fast. You cannot say to people, you need to do this, you need to do this, you need to do that. They'll need to want to do that themselves, right? And that is where it goes. And that is why he says, you need to simplify to amplify. So we started taking away all of the rules and remove them from what we do. And I'll show you what we'll do. I'll just skip this quote. So again, this is my team. I'll show you what we don't do anymore. So this is all the stuff we don't do anymore. Figure that out, right? We don't do sprints. We don't have a Scrum Master. We don't have product owners. We don't estimate. We have a very simple architecture that we tend to adhere to. We actually don't do branching. We don't do pull requests either. We don't do code reviews. Nobody is centrally in the lead. Well, I am a little bit, but my role is more also like make sure that we follow the strategy of the company or that we implement the strategy of the company. But other than that, there's very little rules. And I'm like, well, you don't have a product owner? No, it's our people, my people, go into the teams themselves. So my friend Booster says, well, basically you've become product engineers. I like that phrase, actually. I'm not using it a lot, but it's okay. And that's a good thing. And then we're saying, like, you know what? If everybody goes out and do stuff, we need to share that knowledge. So there's all sorts of mechanisms that we have in place informally, because again, there's no rules here, to make sure that all the knowledge gets spread out over the team. And there's stuff like, well, we solve only one problem per day, but yes, we do vibe coding, and well, these days you need to call it AI assistant coding. And yes, half of my team went back to Cursor, and we're now using it. We're lazy people, right? Developers are lazy by nature. So we write the code, and then we say to Cursor, please write all the unit tests for this particular piece of code. And it does, actually, and it's actually a lot better than it was a couple of months ago. It even started to understand our own framework. So that's a step up, I would say. But most of it, we work together, right? We pair program a lot, right? And they don't look really healthy here because they're probably looking to something very complicated. But and it's not like you have to pair program today. They just do it, right? Or we just do it. I sit next to somebody and say, oh, listen, I have this problem. I don't know how to deal with it. Can you help me out? And that is most of the times much better than the vibe coding that we can do, because, well, it's much better to talk to other people because they also then know what the problem is and they also know it the next time, right? We do it in larger groups as well. Sometimes just people gather together and just sit and work for a couple of hours just with 4 or 5 people just figuring out a complex problem. This usually happens when we go into a very complex problem, like whatever, multi-threading on processes and whatever we do, right? Stuff like that. So yes, these are ways to do that. We also have this. It's called Lean Coffee. We do that every Tuesday. We sit together and we propose topics to discuss, and we vote for it. And the first one gets 5 minutes, and maybe they show something they made that they want other people to use as well, and then we can ask questions about it, and after 5 minutes we vote again, and they can prolong their talk or go to the next topic, and we do this every Tuesday, just to make sure that the stuff we do, the smaller stuff we do that you can discuss in 5 minutes, actually gets across to the other people in the team. And that really works well. So 2 more things that we do is we started to taking small steps, right? The smaller the steps you take, the easier they are to take, right? Don't try to go from 0 into whatever, MCP or responses API or doing very complex things with AI. Start small with a simple example, right? Just do it like that. And also we shortened our cycles because in our company, we have to be aware that there's always the existing platform, the existing system that still needs to run. We cannot just shut down the company for a couple of days because it's an e-commerce company. We'll be doomed, right? And that will happen pretty soon. So that means we need to keep the shop open while renovating. And that you can only do if you take very, very small steps. So we literally try to solve a different problem every day. We break down our problems into problems that are so small that we can almost always solve them in a single day, right? But I did it yesterday. I rewrote a part of the UI on our revenue app, so that the app that shows the sales figures, because we were in the middle of our big quarterly sale, and I just pushed it to production immediately. That helps. The best illustration to do this is this one, right? This is it. This is what you need to do. This is why you need to take small steps. And there's no alternative to that. The thing you need to do to get there is you need to automate everything. You automate everything, meaning, according to Deming, and you always need to have a Deming quote in your talks, is you eliminate the need for massive inspection afterwards, he means, by building quality into the product in the first place. That means that if you are, for instance, doing code reviews, pull requests, all that stuff, that is all done after the deed, basically, right? It's too late. And being too late makes it more expensive, and those costs go up exponentially. So what if you could do that while you were building the code, instead of after you committed it to a branch or wherever you do the pull request, and have somebody else look at it who's not there for the next 3 days because, well, they have a long weekend or whatever they do, or they don't work on Fridays, or so you just have to wait for other people to look at your work. That is highly expensive. So we moved away from that. That's why we do lots of pair programming, lots of mob programming. We work together on code bases, so we know that the code is already okay when we commit it. And that's a big step up. And then we automated everything. We have our pipeline that runs all the way from me checking in the code, in this case, yes, literally, up to all the way to production, right? The changes I made yesterday to the revenue showing app, they went live in about 10 minutes, literally 10 minutes. And the funny thing is, if you start doing that, you go into the direction of delivering more frequently very, very small changes. By now, I think my team releases about 50 to 80 times per day. So I'm not saying you need to do this, but it helps us, because what it does for us, it makes sure that we actually commit our code with a lot of confidence, because the delta is so small that it becomes really easy to test. By the way, we do testing everywhere through the pipeline, right? From the moment I check in my code, we do unit testing, syntax validation, we lint it, and we run our API test, integration test, all the way up to end-to-end tests. We even have tests running in production because, well, code can still break in production, right? Stuff can just fall down, and you need to know that. So we run the test everywhere. And we don't do pull requests, as I said. We also don't do code reviews. I don't like code reviews either. They're boring, right? Usually the people who do the code reviews, they either don't have the time because they're the more senior people on the team, and what they'll do is they'll look at the formatting of your code. No, the square bracket should be on that line instead of that line. It doesn't make any sense, right? So that's what linters are for, right? So usually it doesn't add too much value. So we moved to trunk-based development. Are you doing trunk-based development? Because if you all do that, then I don't have to explain it, right? Trunk-based development means you push back to the trunk. You cannot say master anymore, so it's main or trunk or whatever you do. And that has a bunch of consequences. If you don't branch and you push it back immediately to the trunk, that means you merge with the trunk all the time. That means the longer you wait, the more complicated it gets to merge. That's also on branches, by the way. But when you use branches, you are tempted to keep them there for a longer time. If you don't branch, that means you want to check in as fast as possible, right? I check in my code about 20, 30 times per day. And usually the pipeline starts running and goes to production, but and we all do this. And that means that we make very tiny changes to the code. And the tinier your changes, the higher the quality is, because there's less testing to do, and there's less that can go wrong. So I can definitely recommend it. I'll do a short retro. I have no idea where we are in time, and that's partly my fault and partly because it's a new talk, and also partly because, well, we ran out of batteries, I suppose, at one point in time. So that means you can code with confidence if you do all this, right? And the reason this developer is praying for his code to work is because, well, he works in light mode. Who does that, right? So, short retro. So here's the thing. There's always going to be change. And the change is going to be faster and faster. And in this age of AI, it's extremely fast, right? And you need to stay on top if you want to stay active in this business. If you want to still have a job, you need to make sure that you understand what is happening. That doesn't mean AI is a silver bullet. By far, it's not. But it's getting better, and there's more options that make it more useful. The best thing I can say is that it helps us solve business problems that we could never solve before. So it opens up a whole new barrel of possibilities for us as developers. And we need to make use of that, right? We are becoming the drivers for this AI stuff. And that's good, because we know how to do this. By the way, having faster cars does not mean that you get faster traffic. So this is the slide you showed to management, right? There they say, yeah, we're all going to be replaced by AI because AI can do this much faster, much better. No, it can't. It's good tooling, but it's still tooling, right? We are the ones that solve the problem. It's not the AI that solves the problem. We have to go out to talk to people still and solve those problems. We need to do the thinking. And we can only do this when we take small steps. And by the way, you can never, ever stop learning again in this industry. It's becoming even more important to do this than it ever was. And yeah, that's the whole thing. So we solve the problems, right? So make sure you keep on top of solving the problems and that you see what the tools are offering, what the AI is offering now, which is much more than it did 4 months ago. The pace at which it goes is scary, and you need to stay on top. And the only way to stay on top is to keep invested in this stuff. By the way, if everything else fails, you can always remove your node modules and do an npm install, right? So that's a good point in time to get some coffee, I would say. Thank you for indulging me and for indulging the power outage that I actually predicted during the talk. Well, it happens also to OpenAI, right? So please enjoy the rest of the conference.